Good morning, children. Welcome to Bridge Course. I hope you all are fine and safe. Well, in this class, we are going to see about solutions. Okay, the topic is solutions. In chemistry, a solution is a special type of homogeneous mixture composed of two or more substances. One of the naturally occurring substances is seawater. We cannot imagine life on earth without seawater. It is a mixture of many dissolved salts. The another one is air. Air is a homogeneous mixture of many gases like nitrogen, oxygen, carbon dioxide, argon, neon, etc. All the life forms on the earth are associated with solutions. Plants take solutions of nutrients for their growth from the soil. Most of the liquids found in the human body, including blood, lymph, and urine, are solutions only. Day-to-day human activities like washing, cooking, cleaning, and other activities involving the formation of solutions. Drinks like tea, coffee, fruit juice, aerated drinks are solutions only. A solution can exist in any of the physical state. It may be in solid state or liquid state or in the gaseous state. A solution exists in all the three states of matter. Got it, children? Right. So next we can discuss about mixtures. What do you mean by mixture? A mixture is a material made of two or more different substances. Okay, a mixture is a material made of two or more different substances. So this mixture, it can be either element or compound or both of any proportions. Okay, what are the examples we can give for mixtures? Air, seawater, ink. All these things we can give examples for mixture. How? If you take air, already I told you, air is a homogeneous mixture of many gases, isn't it? Like nitrogen, oxygen, carbon dioxide, neon, argon, etc. Okay. Next one, seawater. Seawater also I told you, it is a mixture of many dissolved salts. Okay. And if you take ink, it is nothing but a mixture of colored dyes only. So these things we can say for example for mixtures. Okay. Mixtures can be classified into two types. One is the homogeneous mixture and another one is the heterogeneous mixture. What is the difference between homogeneous mixture and heterogeneous mixture? If you take the homogeneous mixture, in this homogeneous mixture, the components in the sense ingredients, okay, the components or ingredients are mixed uniformly, okay, or mixed uniformly. We cannot see the components with naked eyes or with the help of an ordinary microscope. Got it? Right. So some of the examples of homogeneous mixture are vinegar, alcohol in water, common salt in water, alloys. These are the examples. Alloys are nothing but it is a mixture of two or more elements. Okay. These elements, it can be either metal and metal or metal and non-metal or non-metal and non-metal. And if you take vinegar, vinegar is a mixture of acetic acid and water, right? So vinegar, dyes, because it can have two or more phases. Okay, it will not mix uniformly, so it will appear as two or more phases. We can see the components easily. Got it? Right. So examples of heterogeneous mixture are smoke, soil, oil and water. Right. So these examples we can see. At the end of this session, I will do some activities based on these things. Right. Got it, children? Right. So what is a mixture? A mixture is a material made of two or more different substances. There are two types of mixture. One is the homogeneous mixture and another one is the heterogeneous mixture. What is the difference between these two? In homogeneous mixture, the components are mixed uniformly, whereas in heterogeneous mixture, the components will not it will not mix uniformly. Okay, so you know about mixture, homogeneous mixture and heterogeneous mixture. Shall we move to the next one? Right. Next we are going to see about binary solution. Okay, what is meant by binary solution? You know about bi means it mentions two, isn't it? A solution which is made of two components are called binary solution. Okay, what is meant by binary solution? A solution which is made of two components or two ingredients are called binary solution. Okay, common examples of binary solution are common salt in water, sugar in water, soda water. Okay, so a solution can exist as a single phase only. Okay, that is why a whole bottle of soft drinks can have the same taste throughout the bottle. Okay, can appear as a single phase. Right? Got it, children? Right. So that is the example for binary solution. What are they? Binary solution means what? A solution which is made of two components are called binary solution. Example, sugar in water, copper sulphate in water, salt in common salt in water. Anything we can say. Got it? Right. Next we can move to solute and solvent. Okay. If you take a solution is made of, okay, the solution is made of two components. One is the solute and another one is the solvent. Okay, this point is very important in this topic. A solution is made of two components. One is the solute and another one is the solvent. Okay, how do you find out which one is solute, which one is the solvent? For this, let us consider two solutions. One is the salt solution, another one is the sugar solution. Okay, in salt solution, salt, that is common salt, is dissolved in water. Okay, in salt solution there are two components. One is the salt and another one is the water. In sugar solution there are two components. One is sugar and another one is water. Okay. In salt solution, we know very well that in salt is dissolved in water, isn't it? So we know that salt is dissolved in water in salt solution, whereas in sugar solution, sugar is dissolved in water. Got it? In salt solution, salt is present in minimum amount, that is smaller amount. Okay, in salt solution, salt is present in smaller amount to form a homogeneous mixture. This is called the solution. Okay, and also in sugar solution, sugar is present in smaller amount. Okay, sugar is present in smaller amount, whereas water is present in larger amount to form a homogeneous mixture. Right? So, in salt solution, salt is present in smaller amount, whereas water is present in larger amount. So, in sugar solution, salt is the solute. Okay, whereas water is the solvent. In salt solution, salt is the solute because it is Whereas in sugar solution, sugar is present in smaller amount, hence sugar is the solute, and water is present in larger amount, so water is the solvent. Got it, children? Now you know the difference between solute and solvent. Solute means the component of the solution which is present in smaller amount are called the solute, whereas solvent means the component of the solution which is present in larger amount are called solvent. Okay, so in salt solution, which is the solute? Salt is the solute because it is present in smaller amount. Water is the solvent because it is present in larger amount. In sugar solution, which is the solute? Yes, sugar is the solute because sugar is present in smaller amount, whereas water is the solvent because water is present in larger amount. One more definition also we can say for solute and solvent. Okay, solute means the component which is dissolved is called the solute, whereas solvent is the medium in which the solute is dissolved is called solvent. Okay, once again I repeat. Solute means the component which is dissolved is called solute, whereas solvent means the medium in which the solute is dissolved is called the solvent. Okay, let me see some examples for solute and solvent. The first example we can say air. Okay, air is nothing but a solution of mixtures only. Air is nothing but a solution of mixture. Nitrogen makes up the largest portion, hence nitrogen is the solvent. Okay, nitrogen is the solvent, whereas other gases like oxygen, carbon dioxide, argon are present in minimum level. So these gases act as a solute. Got it, children? Nitrogen makes up the largest portion in air, hence it is a solvent, whereas other gases are present in minimum level. So those gases act as a solute. Got it? Right. Next one, sugar syrup. In sugar syrup solution, you know very well, sugar is dissolved in water by applying heat, isn't it? Here in this sugar syrup solution, sugar acts as a solute because it is present in minimum amount, whereas water acts as a solvent because water is present in larger amount. Got it? Right. Next one is vinegar. Vinegar is nothing but the mixture of acetic acid and water. Okay, here acetic acid acts as a solute because it is present in smaller amount, whereas water acts as a solvent because water is present in larger amount. Got it, children? Good. Next one is milk and sugar solution. Okay, so here in milk and sugar solution, you add sugar in minimum amount only, isn't it? So sugar acts as a solute, whereas you take milk in larger quantity. So milk acts as a solvent. Understood, children? Now you know what is the meaning for solute, what is the meaning for solvent, and also we saw some examples. Shall we move to the next one? Good. Next we can move to types of solution. Okay, types of solution. So there are different types of solutions are there. That is aqueous solution, non-aqueous solution, and then concentrated solution, dilute solution, saturated solution, unsaturated solution, supersaturated solution, like that. When you go to higher classes, you will learn about this in detail. Okay. So this session we are going to discuss about 4 solutions. One is the aqueous solution, non-aqueous solution, concentrated solution, and dilute solution. These things we are going to discuss now. Got it? Right. First one is aqueous solution. What is meant by aqueous solution? The solution in which water acts as a solvent. This is called aqueous solution. In the meantime, I will tell you one thing. We are using not only water, we are using many solvent. Okay, but specifically we will say water is a water has the capability of mixing or dissolving so many different substances. Okay, water has the capability of dissolving many different substances. That is why we are saying water is a universal solvent. Got it, children? Right. So first let us discuss about aqueous solution. Aqueous solution means the solution in which water acts as a solvent are called aqueous solution. Okay. Common examples are common salt in water, sugar in water, copper sulphate in water. Okay. All these things dissolve in water, you know very well, isn't it? Common salt in our day-to-day life we are using. Sugar is also we are using in the laboratory. Copper sulphate is used. So all these things dissolve very well in water. So that is called the aqueous solution. Okay, aqueous solution means what? The solution in which water acts as a solvent. Underline this word. This is very important. The solution in which water acts as a solvent are called aqueous solution. Got it, children? Right. So next one is non-aqueous solution. Here the solution in which any liquid other than water. Here we are not using water as a solvent for non-aqueous solution. Okay, non-aqueous solution means the solution in which any liquid other than water used are called the non-aqueous solution. Got it? For example, we can say acetone dissolved in oil, ethyl alcohol dissolved in oil. Ethyl alcohol dissolved both in water as well as in oil. Okay, and then sulfur dissolved in carbon disulfide. Okay, these things, iodine dissolved in alcohol. All these things we can give examples for non-aqueous solution. Here the solvent we are not using water. Instead of water, other substances we are using for solubility, that is solubility purpose, for mixing purpose. Okay, so what is non-aqueous solution? In non-aqueous solution, a solution is used, that is instead of water. Okay, instead of water we will use other solvents, that is called non-aqueous solution. Okay, a solution in which except water we can use other solvents for non-aqueous solution, but for aqueous solution we use water as a solvent. That's the difference between aqueous and non-aqueous solution. Okay, next one is concentrated solution. Concentrated solution means a solution in which larger proportion of solute is added, then it is called the concentrated solution. Okay, a solution which contains large proportion of solute, then it is called the concentrated solution. For example, we can say hydrochloric acid, sulfuric acid. These are concentrated acids. By using water we can dilute these acids. Okay, but when we buy this concentrated, when we buy this sulfuric acid and hydrochloric acid, that time it is in the concentrated form only. Okay, we can, if we want, we can dilute it by using water, right? So concentrated solution means what? A solution in which contains large proportion of solute or concentrated solution. Next come to dilute solution. What is meant by dilute solution? Here a solution which contains lesser proportion of solute. Okay, larger proportion of solute means then it is called a concentrated solution. At the same time, if we add lesser proportion of solute, then we can say it is a dilute solution. Example we can give seawater. Seawater is a dilute solution only. Why? Because in seawater, minimum amount of salt is present, whereas maximum amount of water is present there. So seawater we can give examples for dilute solution. Okay. Now you know the different types of solution, children. Aqueous solution means we are using water as a solvent. Here, instead of non-aqueous solution, instead of substances. The same example we can give: salt in water, sugar in water. That we can give for true solution, because the solution is made up of two substances. One is water, another one is salt. If we add salt, then two components will be there. So those components will mix uniformly throughout the solution. Then we can say it is a true solution. The last one, properties of solution. Okay, solutions have some different characteristic properties. Some of the properties are: first one, solution is a homogeneous mixture. Okay, homogeneous mixture means what? Mixed uniformly. Got it? So first one, a solution is a homogeneous mixture. Second one, a solution it can be always transparent in nature. Okay, a solution can be always transparent in nature. It may be either color or otherwise colorless. Okay. Next one, we cannot see the particles of solution with naked eyes or with the help of an ordinary microscope. Okay, we cannot see the particles of the solution. It is very small. We cannot see by naked eyes or with ordinary microscope. With the help of the special type of microscope only we can observe the particle size of the solution. Got it? So what are the three properties? One is a solution is a homogeneous mixture. We cannot see the particles. The particle size of solution is very small. We cannot see it by naked eyes or with the help of ordinary microscope. Solution is always transparent in nature. It may be either colored or colorless. These are the different properties of solution. Got it, children? Right. Okay, children. Now we can start the activity. So the first activity is homogeneous mixture. What I told you for homogeneous mixture? In a homogeneous mixture, the components or ingredients are mixed uniformly. That is called homogeneous mixture, isn't it? So we are going to do one activity based on this. Okay. So two things we require for this. One is I am going to use acetic acid as well as water. It is nothing but vinegar solution. Okay. So take one beaker like this and add some water into it. Take a beaker and add some water. Okay, now I am going to add some acetic acid into it. Okay. So this is acetic acid. It is a colorless liquid. But you should not use with bare hands. Okay, properly gloves and all we have to wear. And with the help of the adult only you should do this experiment. You should not try this experiment at home. Keep this point in your mind. You have to do it in the laboratory only with proper guidance. This point you have to remember. Right, children? Good. So I added water. Now I am going to add some acetic acid into the water. Immediately you should close the acetic acid. Right. Now I am going to mix these components. What are the components I added? One is water, another one is acetic acid. Okay, what do you observe now? You will observe that the acetic acid completely dissolves in water, isn't it? Here the components appear as a single phase, but you cannot see the components with naked eyes or with the help of the ordinary microscope. See, you can see only one phase. I added two components, one is water, another one is the acetic acid. Both gets mixed. Okay, so it is nothing but the vinegar solution. Vinegar is nothing but the mixture of acetic acid as well as water. It is an example of homogeneous solution. Homogeneous solution means what? The components mixed uniformly. Okay, see the components, both the components mixed uniformly, and you can see a single phase only one solution, isn't it? So So it is an example of homogeneous solution. Got it, children? Right, shall we move to the next one? Good. Second one, I am going to do heterogeneous mixture. For this heterogeneous mixture, I am going to take two components. One is water and another one is oil. Before that, what do you mean by heterogeneous solution? In heterogeneous solution, the components are not uniform. Okay, it can have two or more phases, but we can see the different components with our naked eyes. That is the heterogeneous mixture, isn't it? So I am going to add some water first in the beaker. Okay. Next component I am going to add some oil into it. Okay, already I added water. Now I am going to add some oil into it. If you mix these two, will it get mixed? See, what do you observe from this? What do you observe? Here you will see the two phases. Okay, one is the water phase, and here see, if you see the top phase, upper layer is oil. Water as well as oil, it will not get mixed. Okay, so that is the heterogeneous solution, heterogeneous mixture. Heterogeneous mixture means what? Heterogeneous mixture means the components are not uniform. It can have two or more phases. We can see the components with our naked eye. So this is the water, below water layer. In the top layer you can see the oil. So two phases are there. We can see, isn't it? I can see the oil layer as well as I can see the water layer. It will not get mixed. Okay, the components are not uniform. Then we can say it is a heterogeneous mixture. So this oil and water is an example for heterogeneous mixture. Understood, children? So now you know the difference between homogeneous and heterogeneous. Homogeneous means components mixed uniformly, whereas heterogeneous means components are not uniform. Instead of this, you can use many samples, many substances you can use. Okay, right. What is the third one? Third one is solution. Okay. Let us consider 3 glasses of water. Right. Now we are going to do activity for solution. What is meant by solution? Already I told you, solution is a homogeneous mixture composed of 2 or more substances. Right. Okay. So first I am going to take 3 glasses. Okay. And I am going to add some water into it. Measurement is very important, children. In the chemistry laboratory, we should use the measuring flask. Okay. Here I am not having, that is why I am taking approximately. But experiments and all, you should use accurate measurement only, right? So the second beaker or second glass, again I am taking water. In the third glass also. See, equal amount of water I have added in all the 3 glasses or tumblers. Okay. Now what I am going to do is, I am going to add some salt into the first beaker or tumbler. Okay. I am going to add some common salt which we use at home. I am adding common salt into the water. Right? Okay. And mix it well. See, salt gets dissolved in water. Okay, salt gets dissolved in water. We know very well, common salt is soluble in water. Okay, and forms a homogeneous solution. So, salt completely dissolves in water. So, salt is soluble soluble in water and forms a homogeneous solution. So hence it is called a solution. It is the homogeneous solution, right? Next, you can go into try with sugar substance. Okay, we are going to take sugar now. Okay, now I am going to add some sugar into it and mix it with. So what do you observe now? The sugar completely dissolved in water. So we know sugar is soluble in water and forms a homogeneous solution. Okay, so it is a homogeneous solution. Next I am going to try with sand. Okay, already water added. Now I am going to add some sand into it. Okay, sand and mix it well. What do you observe now? Even though if you mix it well, definitely sand will not dissolve in water, isn't it? See, there are two phases here. One is the water phase and another one is the sand, isn't it? So, this is not a solution, it is a heterogeneous mixture. Heterogeneous mixture means what? The composition is not uniform. Okay, what are the components we are adding? It will not get well mixed. Okay, it will not mix it well. Hence, it forms a heterogeneous solution. So, heterogeneous mixture. So, it is not a solution. The sand solution, we cannot say it is a sand solution. It will not come under the category of solution. It is just only a heterogeneous mixture. Okay, but at the same time, if you take salt and sugar, we can say it is a homogeneous solution. This is also a homogeneous solution because both the solution get mixed well, uniformly gets mixed, and we can see the single phase only. Okay, also components we cannot see, but at the same time if you take this sand, here we can see the two components, water as well as sand we can say. So it is not a solution, it is only a heterogeneous mixture. Understood, children? Now you know the difference between the homogeneous mixture and heterogeneous mixture, isn't it? So next one, the solution, you know, solution means what? It is a homogeneous mixture of two or more substances. What are the substances I added here? One is salt, another one is water. Here I added sugar, another one is water. Both gets mixed. So these are the examples of solution. This is salt solution. This is a sugar solution. This is not a solution. It is only a heterogeneous mixture. Understood? Right. Next we can move to binary solution. What is meant by binary solution? Already I told you binary solution means a solution made of two or more components. Two components, not two or more. Two or more means it will come under trinary, ternary, like that it will come. Okay. So two components, a solution which is made of two components, then it is called a binary solution, right? So what example we are going to do now? Now I am going to use two components. One is the baking soda and another one is water. Okay, the chemical name of baking soda is sodium bicarbonate. Okay, so I am going to use baking soda as well as water. Now I add some water. So this is the baking soda. It is the chemical name is sodium bicarbonate. Usually we use this at home to prepare cake as well as for puri preparation. Okay, we use this. This is the baking soda. It is a white salt. Right. Now I am going to use some baking What do you observe now? You will observe that the baking soda completely mixed with water. How many components I added here? Two components. One is water, another one is the baking soda, isn't it? So it forms a solution. Binary solution means what? A solution which consists of two components, baking soda as well as water. Not only by using baking soda, we can use salt water, sugar water, copper sulphate in water, anything we can use. If we use two components, if it gets mixed, then it will come under the category of binary solution. Understood, children? Shall we move to the next one? Good. So next one is solute and solvent. Okay. I told you solute means if a component, what are the component we are adding? If it is in the smaller amount, then it is called the solute, and component if it is in the larger amount, it is called the solvent, isn't it? Okay. Now I am going to use two components. One is sugar, another one is water. Got it? So I add some water. Okay, I added 100 ml of water. Now I am going to add some sugar into it. Say 100 ml of water I added. Here see the sugar, it is nearly 2 grams. Okay, so now I am going to add the sugar into water and mix it well. It forms the sugar solution after mixing. Here two components I added. One is water, another one is sugar. Water I took in larger amount, whereas sugar I took only smaller amount. Hence, sugar is the solute here. At the same time, water is the solvent. Why sugar is the solute? Because sugar I added a minimum amount, isn't it? Lesser amount, whereas water in larger amount. Okay, now you know the difference between solute and sugar, isn't it? Okay, one more experiment we can do for this solute and solvent. Okay, for this I am going to take two components. One is milk, another one is sugar. Add some milk. Okay, next I am going to add some sugar. See the milk quantity and see the sugar quantity. So after mixing you will get the milk solution, isn't it? Here milk I have taken in larger amount. Hence milk is the solvent here, whereas sugar is the solute, because sugar I added in minimum quantity. Understood, children? Right. So next we can move to aqueous solution. So aqueous solution means what? The solution in which water acts as a solvent is called aqueous solution, isn't it? Example, salt in water, sugar in water, both the experiments we did. Next, we are going to do one activity by using copper sulphate. Got it? Copper sulphate. Okay, now I am going to take some water in the beaker. Next I am going to add some copper sulphate. So see the copper sulphate, one of the beautiful chemical in the chemistry laboratory is this copper sulphate only. Okay, beautiful blue color. So I am going to add some copper sulphate into it. Okay, now I am going to mix it well. This we are doing for aqueous solution. Aqueous solution means solution in which water acts as a solvent. Mix it well. See what happens after some time. Copper sulphate completely dissolved in water. Few more salt is there, for that we have to mix it well. another one is copper sulphate. So here in this solution, water acts as a solvent, whereas copper sulphate is the solute. Okay. So aqueous solution means what? The solution in which water acts as a solvent is called the aqueous solution. This copper sulphate in water is an example of aqueous solution. Understood, children? Right. So next experiment, non-aqueous solution. Non-aqueous solution means what? So the solution in which other than water acts as a solvent are called non-aqueous solution. Here for this non-aqueous solution we should not use, that is we are not going to add water, but instead of water other solvents we can use. Okay. For that I am going to try with acetone as well as oil. I am going to take some acetone. Acetone is nothing but a solvent only. So add some acetone into it. Okay, now I am going to add some oil, right? Few drops just add and mix it well. Acetone gets mixed with oil as well as acetone mixed in water also. So this is a non-aqueous solution because instead of water I have added acetone. Okay, I have added acetone as a solvent here. Water, I didn't add water. Instead of that water, I have added acetone. Acetone is a solvent only. Acetone mixed with oil. So it gets mixed. So this is the non-aqueous solution. Okay, non-aqueous solution means water we should not use as a solvent. Instead of water, we can use sulfur dissolved in carbon disulfide, ethyl alcohol dissolved in oil, okay, and then acetone dissolved in oil. These are some of the examples. Right. Next one, concentrated solution. Concentrated solution means a solution, okay, a solution with a larger proportion of solute. A solution which contains larger proportion of solute are called concentrated solution, whereas dilute solution means a solution with a lesser amount of solute are called dilute solution. Okay, now look at these two. Look at these two. Okay, so what do you observe from these two solutions? If you look at this solution, it is highly concentrated because the solute has more in quantity. Okay, the solute has more quantity, larger quantity. That is why it is highly concentrated solution. At the same time, if you look at this solution, here the solute present in lesser quantity. So this is the example for concentrated solution and dilute solution. Look at this difference. See, this is highly concentrated. This is the dilute solution. Now you know the difference between concentrated solution and dilute solution. Good. The last one, true solution. True solution means it is nothing but a solution with a uniformly mixed. Okay, a solution which if it is uniformly mixed, then it is called the true solution. Okay, true solution is made of two or more different substances. The last experiment. Okay, so I am going to take water. Just add some baking soda or otherwise common salt or otherwise sugar into it and mix it well. Now I added salt, common salt. Mix it well. This is an example of true true solution. A true solution means it is a solution in which the components are mixed uniformly. Okay. So a true solution consists of two or more different substances. Here I added two components. One is water, another one is the common salt. So this is an example of true solution. Understood, children? Okay. So what are the